So my name is Jim Zimmerman. I'm Principal SDE, Engineering Evangelism and Engagement in CSE. So CSE is the new org. It used to be called TED, for those of you guys familiar with Microsoft, and now it's Commercial Software Engineering. So.
Yeah, hi, and I'm Patrick Lang. I'm a Senior Program Manager on the Windows Container Engineering team. So our team builds the technology in Windows, and then we put Docker and other things on top of it. So.
Yeah, and I guess I forgot to mention, in my group, I mostly focus on Kubernetes and Linux. And so what we thought we'd do is I filled in for Gabe Monroy today. He had to leave. So I'm here to take his place. And I mostly just hack with end customers with Kubernetes and Linux in Azure. So it's a lot of fun. Love my job. So how many people here are using containers in production right now? Okay, so about 10%-ish. How many are exploring to use it? So you're thinking about it. Okay, yeah. So this is a perfect session for you. Yeah, and then I don't know about.
And so out of those of you that are exploring containers, how many of you are working on Windows? Looks like the majority. Windows and Linux. All right.
Okay, so about half for those. They are recording this session, but they're not. They're only recording the audio and the screens. So we may repeat a lot of the questions you ask and things. So it's about half the room's using mixed workloads, which is about what we thought, maybe even a little bit more. Cool, so we'll go ahead and get started. We got some fun demos for you today and a bunch of stuff.
All right, so where do developers spend their time today? The majority of the time starts off with, debugging existing applications. It's not fun, but, someone's got to do it because it has to be, you have to keep that app up, and that's just sort of, the cycle of it. It's called live site. And then after you're done debugging and keeping your business running, then you get to actually spend some time adding new features to existing applications. And after that, after a few people add features, of course, now you got to go fix the feature that someone else added. Maybe it's a bug. Some people call it a feature. I don't know. It's all the same to me. I used to be a tester, so bug feature, it doesn't matter. I get the scorecard for it. And then what do you do after that? Well, you build out new applications if you have time. So one of the big things that we're trying to do is make sure that we're always building tools that enable both developers and operation engineers to be more efficient in what they're doing. And containers are a big part of that. So let's look a little bit at the application admins. So the first thing you got to do is, of course, you got to keep stuff running. So you're maintaining your existing applications. You're redeploying them because you've got to cycle hardware in and out. Who loves migrating across hardware? Yeah, it's great. No, nobody likes that. And it can be quite a pain, especially if your workbooks aren't kept up and all of that. And then, of course, once you migrate, you got to diagnose issues with it yet again. Same cycle. You got to keep it running. And then troubleshooting feature additions from the devs. Features, bugs. I don't know. They're getting paid based on commits, right? No.
Hope.
And then once you have time after all of that, then that's when you get to deploy the new applications, where the most fun is. But what we're going to show is that containers help streamline this entire cycle. And as we'll get to in a bit, Kubernetes is one of the tools you can use to manage your containers here. And so when we've got existing apps, we have to have a way to basically keep them alive. We can't throw them out. We can't stop adding features. We got to keep business running, but containers are a way that we can make that a lot easier for everybody involved. And it also gives us a path to start deploying new code alongside the old code, which is a great way to help move your business forward. There are a couple sessions earlier in the week that you should be sure to check out. I've got a slide at the end, but there were 2 sessions just dedicated to migrating apps and then amending them with new functionality using microservices. And so I've got the session codes at the end, but if you want to know more about the nitty-gritty details of how to actually do those migrations, be sure to check those out. So So where do we start? Well, the first thing that we can do with containers is we can go ahead and start with existing applications. Oh, wrong. Nice picture, but not the one I was looking for. Instead, we get to look at this ugly code, but it's important. So what I have here is a relatively traditional web app. This is one that's been used at a lot of Microsoft conferences in the past, and it's some Visual Studio training tool, and it's an application that was called Fabricam Fiber. And so basically, it's a relatively straightforward ASP.NET app. We've got the controllers, all that code here. But this was an existing project that I downloaded online. And then I used the tools that were already built into Visual Studio to go ahead and add Docker support to this. And then I've got, of course, Docker for Windows available on my machine here, because that's what I can use to actually build the containers. So when you start this process, you can start it anywhere. Even though I'm going to deploy this on a server, as you see, I'm just running it right here on this Win 10 laptop. So let's hit go on this. So right now, what that plugin did behind the scenes was it actually built up files that actually describe how to build all of this. So we've got the Docker file, which is a description of what needs to go into the container. So we see that it's starting from an existing ASP.NET image. We're setting a working directory there for all the later commands, and then we go ahead and copy in the website files and finish configuring it. And then we also have another file that describes how to actually deploy it. One of the things I did here for this local development environment is I decided to actually bring up a fresh, clean database for testing as well. That way I don't have to deal with managing a SQL install or figuring out differing connection strings for a shared server or anything like that. I'm just running it all locally here. So I've got two services defined. This one is the website, and it's on port 80. And then I'm also asking for a database using the SQL Server Developer Edition. I'm following a really bad security practice here of putting a password in this. This isn't what you should do in production because anybody could see it from the logs, but hey, for just running on my laptop, unless he kicks me off the keyboard, I don't have to worry about anybody breaking in.
And you're running that SQL Server in a container?
Yeah,
in there too.
yeah.
Okay.
So this is going to be launched in 2 containers here. And if I scroll down to the bottom here, it should be building those right now. Or actually, maybe it's already running. It's always fun when you just have a blinking cursor there. All right, so let me see what containers are actually running behind the scenes here. So because these containers are all managed by Docker, I should be able to just go over here and get the list of running containers.
Is it the one you deployed to the server?
No, this is one on my laptop that I've deployed over and over and over and over again, and I probably ran out of disk space doing so because
that was yesterday.
Well, that was yesterday. I don't know. It's all a blur. But
well, maybe we could deploy it to the server.
Yeah. Well, we'll come back to that. So, but anyway, the key thing here is that I initially built the containers here, and then I actually went and published them on hub.docker.com. All right, Patrick Lang. And somewhere in here, and all these images I've published, all the way down at the bottom, once it was built, I took the final result, and then I pushed it to Docker Hub, which is something that's known as a container registry. So you could run a container registry, both on your own site, or you could use a public one like Docker Hub, or we have one on Azure as well called Azure Container Registry. But this is basically the place where I would hand my code off from a developer over to the operations team so they can actually deploy it. So anyway, I've built a container. I've already got it pushed to a registry. So let's go ahead and move on here, because we'll come back to actually deploying it from that registry.
5.
Oh, I hit 6. All right. All right, so that was an example of how to actually build apps that works most of the time. I've done some bad things to this laptop, so I don't know what I need to do there. So anyway, so build the app, but once I want to actually move it from running on my laptop that's overloaded here, I'd like to run it on a nice big set of servers in the cloud. And to actually do that in production, you would use what's called a container orchestrator. So what container orchestrators do is help you move from an environment where it's just a single machine. Maybe you've got a few services connected, like I had the web and the SQL, but it actually lets you scale this across multiple machines. So at a basic level, being able to schedule things across multiple nodes is kind of the most basic thing they do, but that's not all of it. So some examples of container orchestrators are Docker Swarm, which is the open source underpinnings for Docker Data Center. We've got Kubernetes, that's what we're here to talk about today. We've got Azure Service Fabric, and then Red Hat also has a product called OpenShift, which is also built on top of Kubernetes. And so today we're just mostly focusing on the Kubernetes and OpenShift. I've also got sessions on Docker Swarm and Service Fabric in the notes later. So what do container orchestrators do? Well, the first thing they do is give you a way to declare what you want to deploy. This is really important because you can do all this in code, which means you've got something that is 100% repeatable. That's very important because with a lot of older tools, if someone forgot to hit a checkbox, my favorite example would be, how many of you have installed SQL? For most of the crowd, it looks like. The mistake I make almost every time when I'm installing SQL is I'm going through there, I set up the name of the database, I pick the account it runs under, and I forget to hit the checkbox to add me, the logged in user, as an admin. Yeah. And then so once you get to the end, well, I can't get in. And I generally follow the best practice of leaving the SA password off, so what do you have to do? Yeah, you just have to start over from scratch. And I've done that so many times. I've wasted so many hours of my life on that because I do it so infrequently. But that's just an example of why it's so important to be using infrastructure as code to actually be able to do these deployments, because it lets you make your ability, it helps you extend your abilities so far so that you can get so much more done. So once you've defined what needs to be deployed, the orchestrator uses a process called desired state reconciliation. So what it's doing is looking at all the deployments you've told it to do and to make sure that they're still right. So if something happens, like you've got a node that went down, like maybe one of my hosts went down, maybe your laptop hung or so, well, that's almost not in the orchestrator, but you had a machine hang or whatever needs to be done there, it'll just fix the problem by killing any containers that need to be shut down and starting new ones in their place. And if they're missing, or you want to actually scale them out further, you can just update your deployment and then scale that right back out. And so because the container orchestrator is separated from the actual application that's running, that helps you get really high reliability because you can focus on making the thing that monitors everything else really, really reliable, because it's just doing that one task. It's not intermingled with anything else at all. And then, of course, there's hooks for health monitoring as well. So that means that if I wanted to set something up where if that website stops responding, just go ahead and kill it and restart it. It all happens behind the scenes. So those are just some of the examples of things you can do with a container orchestrator. Go to the next slide. Oh, there we go. All right, so why Kubernetes? There's 4 different options out there, and there's actually more that weren't even on the slide. But why did we start going down the path of building this? And the real reason why is that people have asked for it. A lot of companies are looking to modernize their applications, and because there's all these mixed environments out there, there's a lot of different choice in tools. So we want to make sure that we're able to help customers pick and choose from whatever tools they want to use to get the job done, whether it's on Linux or whether it's on Windows. So Microsoft is committed to open source, and so we've made open source contributions along with a bunch of other partners to actually get that done. But Kubernetes is one of the most popular orchestrators, so we started going down that road. And so when you're picking a container orchestrator, you want to make sure that you're looking at some of the same key capabilities. So one example would be load balancing. It's no good if you just have a single point of failure, so you want to make sure that you can actually distribute load across all the different nodes that you have there. And then because containers can move around from one place to another, you want to make sure that they've got a way to be able to locate and identify each other. So in the case where I've got a web and a database, I don't want to have to hard code an IP or make other changes like that in order to keep them, just in order for the containers to be able to come online. I want that to be dynamic. And then once things are running, I need to be able to monitor how they're doing, check logs, and then of course do some debugging and introspection on them. Because as we said, apps are never perfect. Things are going to break, so we need to have a way to be able to look into that. And then there's also, of course, what good is a server application that can't talk to anybody? So we need to make sure that you're automatically configuring the networks in a secure and predictable manner. So all of these are things that Kubernetes is able to do. It's got self-healing capabilities. We'll probably see that later because I'm sure I'll break something at some point. It's got horizontal scaling. So let's say you wanted to be able to scale something out to meet peak load, but then collapse it back down to fewer instances to save money later. It can help you do that. You can automate your application rollouts, set rollback policies, so when things do go wrong, you've got your code and you can just bring it back to where it was. Service discovery, load balancing, and bin packing. So bin packing is commonly used in the Linux community to basically refer to putting a whole bunch of things on the same box. You might call it shared hosting or something like that, but I don't particularly like the term, but it's the term we have. And then you need to make sure that you're able to configure storage when things are need to be persisted, and be able to handle configuration and secrets. All right, and so where did Kubernetes come from? I mean, that's a great question. It initially started out as a project at Google, co-founded by Brendan Burns, and I can't remember the other co-founders off the top of my head, but basically, at this point, we're up to over 1,700 contributors to the Kubernetes project. This chart here shows some of the projects with the most commits on GitHub for, roughly for about a year date range there. But Kubernetes reached 1.0 in 2015. When that happened, of course, there wasn't Windows support. We started working on that later. And all the authors basically have a great way to collaborate because they've organized into different special interest groups that all have dedicated Slack channels. They have regular meetings. And so it's a very collaborative engineering effort. And right around the time of 1.0, this also moved into what's known as the Cloud Native Computing Foundation. And so the Cloud Native Computing Foundation is actually the governing body that has stewardship of this project. And so Kubernetes is probably the most well-known, but they've got a whole bunch of other projects that are all focused around giving people the best tools to do large-scale applications in the cloud. And so the Cloud Native Computing Foundation owns the trademarks and things like that, but then there's a very wide group of members in there as well. If I can find the right page.
It's in about.
Oh, it's under About, okay. Oh, right there, the first one. But one of the things that's great about having a separate project own this is, if you look at the companies that are helping support this, you've got a whole bunch of companies that would normally be competitors collaborating together. And why are they doing this? It's to give you, the customer, the best tools for the job, and in a way that gives you the flexibility you need, and if you want to contribute and add new features, you're welcome to do so. So it's a fantastic development model, and Microsoft is extremely committed to open source, and this is one of the biggest projects we've done so far. All right, so getting Kubernetes on Windows. So back in 2016, while we were in technical previews with Windows Server and getting ready to launch last year, Apprenda and some others basically announced that they were going to form a new group, SIG Windows, within the Kubernetes project. And so Apprenda, Google, Microsoft, Red Hat, and a number of others have all been contributing to this effort. And they basically reached a 1.5 alpha release in December just last year. And since that initial alpha, the project's been moving at a tremendous pace. Cloudbase ported their OpenStack plugin that is able to do cross-platform software-defined networking using OVS and OVN to work with there. So now all of a sudden you had something where Windows could talk to Linux. Microsoft Azure team also did integrations so that you could use storage and networking directly from Kubernetes. And then we've added support for Windows resource metrics, so you could look at container resource usage and make that gives you the ability to choose where to place things more intelligently. And then we've also been working on standards-based network plugin that follow the CNI model. When CNI is basically like the plugin standard for Kubernetes. And there's a lot more to come. But anyway, I've talked too much. I think at this point, it's time to kick it off and do the first demo. So, all right, so
cool.
Take it away, Jim.
So how many people here have used ACS Engine at all? Just kind of curious. Okay, not many, so like 6 or 7 people. So I'm going to show you how we deploy more complex clusters in Azure. So this will not work. You can't go to the portal and click a button. You have to actually download ACS Engine and compile it and generate templates. So I'm going to show you how to do that. And then what the cluster I'm going to be publishing is mixed Linux and Windows workloads, with the master being in Linux and controlling both Linux and Windows nodes, right? It's pretty cool to see. So as was this in Oregon, by the way. Okay, so I'm not going to show you how to actually build it in Docker, just because it takes time, and it's going to update Ubuntu, and it's going to do all these things in Docker. But what I will show you here is after you get it downloaded, and this will work on Windows or Mac or Linux or whatever. It's in Go, so you have to have a Go environment set up. You have to have your Docker environment set up, and then you just do a make dev environment. And then it'll pop up Docker container, and then inside the container, this is when you generate the ARM templates, basically. And then you deploy the ARM templates. So this Docker image has AZ, or CLI tool, built into it. So basically, it's one-stop shop. Now, it isn't trivial to get Go and Docker and everything set up on your machine, so I will say that. But if you already have that set up, then this is actually pretty straightforward. So the first thing we need to do, I have some cheats, so I don't have you guys watch me mistype things here. So basically, after you get everything compiled, you go to ACS Engine, and you generate, and then there's an example that we have in the repo, and I will bring that up so you guys can see how that works. But Basically, you pick your orchestrator. So obviously, with this, it's Kubernetes and 175. So this is bleeding edge stuff. So this is not something that you're going to see in ACS in the portal. I think we're at 166 now in the portal.
Oh, so what's the difference between ACS Engine and ACS?
Yeah, so ACS is, it's in the portal, so it's already predefined. It's the one that's supported. And then if you go to ACS Engine, you can pick like what version. So if you want to test features in 175, there's a lot of, I'm not going to get too into it, but like after 1.72, we now support managed disks with Kubernetes, which is super important. And attaching disks is probably about 20 or 30 times faster. Right now, it takes like 5 minutes, and in 172, it takes 19 seconds.
Yeah. So it's a place where you get to try all the bleeding edge features.
So we're constantly iterating on here and all that. So this is a good question, actually. So so the master profile, you just basically give it the DNS prefix. I call it Kubernetes Linux Win for this demo, and then you pick your VM size. I highly suggest picking the DS2s, or that's the cheapest one that will add premium storage. Just when you're doing this and when you're doing dev tests, it's so much faster if you're using SSDs when you're attaching disks and doing things, that I highly suggest just pay a little extra money. It's like a penny or two extra than the D2s. And so I highly suggest that. It's a much better experience. And then here's my Linux pool. So I have 2. I could easily make that 10 in my Windows pool. And then I'm not going to scroll down for my SSH keys or my service principals, because this is being recorded, and I can just see someone pausing it just to mess with me. So we're not going to do that. Okay, so with ACS Engine, we're going to go ahead and generate this template. And what's going on here is it's taking that variables file that you saw, and it's generating an ARM template. And I'll show you the ARM template here in a second. Okay, now it's done. And so I'll go over here, make sure I'm in the right directory. Okay, I'll refresh that guy. Where are we at now? Okay. All right, so what did I call it? Linux Win this time, okay? So basically what's going on is it generated your kube config. Okay, so this is important because in your kubectl, like you can run kubectl locally. It's the CLI tool for Kubernetes. You can change the config on your local computer to be this config that's in here. Basically, you have to pick the one, like I deployed it to, I'm going to deploy this to East. So in East here, you'll see there's my config, basically. Anyway, that's not important for this demo, but I'm just kind of giving you guys an idea of what's going on here. And then here's the Azure deploy JSON file, okay? Huge file, a bunch of stuff. And then here's the parameters of everything, the certs, it self-signs the SSL certs for TLS communication. And so once we do that, we're going to go ahead, and I'm definitely not going to try to remember to type this group deployment create. So I'll go ahead and yes, it worked. So sometimes you do this and then, oh, I need to do AZ login, and then I have to have it call my phone and all that stuff. I didn't have to do that on stage. That's great. So, and then here's my my command to deploy. So basically, it's a group deployment. I have to have already created the resource group, which I just did. And then there's my template file and my parameters that were just generated. Okay, so I'll go ahead and do that. And then while that's starting, I'll go ahead and show you that this is actually really happening right now. Okay, so you see here it's deploying. So if you run into any issues, like here, it's not going to give you the errors, right? So it's going to say running here for about 7 minutes, 10 minutes, depending what region you're in, what size VMs you're using and stuff. But if you want to actually watch it and see what's going on, if you go into the portal, you can see, okay, now there's 17 items. So it looks like it's got the VM started and all that. So if you go to deploying here, you can actually look at the logs in detail. Sometimes you will run into issues because you're running bleeding edge stuff with ACS Engine, so there may actually be a bug in the version of Kubernetes that you're deploying. You never know. So sometimes I use this a lot when I'm deploying my own version of Kubernetes, because like I'm changing code inside of upstream and then deploying it this way, and it doesn't always work. So. All right, so while that's going, there's no reason to wait to get the demo going. So I already have a cluster up here. I'll show you that it's here. I called it JZ Kubernetes Win. So there's my cluster there. So you see I have 2 Linux, 2 Windows nodes. So what I'm going to do is I'm going to go ahead. There's a sample in ACS Engine that you guys can all play with that's done by Anthony Howe on the engineering team. And it's an ASP.NET to-do app that's running on Windows, and I think it's a legacy .NET app like 3.5, right? Running in a Docker container, and then but talking to a Redis server running in Linux on Kubernetes. Okay, so shows you that they both will work. So let me make sure I am in the right directory. Okay, there we go. So did I close the other one? Yes, I did. Okay, let me open this up. So I want you guys to see the hybrid. Where did I go? Hybrid right here? Yep. So everybody familiar with the pod spec like in Kubernetes? Everybody familiar with what this is? Okay, hardly anyone. Okay. Okay, so basically this is like your definition file. Think of it as like you're declaring what you want Kubernetes to deploy. Okay. So I wanted to deploy a service for the Redis, okay? And here's the ports that I want it to be on. And I'm not going to go too deep into Kubernetes because that's not the point of this talk. This is not advanced Kubernetes training or anything, but I will explain at least this part. So we have a service that we're going to deploy. We have a deployment with the replica of 1. Now I could easily say I want 3 replicas, and then so I make sure that it's on Kubernetes will make sure it's on 3 different nodes, right, for HA. And Kubernetes does this for you if I change that to 3. And then, there's just some metadata here that I can use for when I'm doing builds and things like that. And then, and then here's my containers. Here's how much CPU I want it to max out at. Here's how much memory. So if it goes over that memory, don't do it, right, in case there's a bug or something. I don't want it to take over the whole server. And then, importantly, I say, well, what's the node selector? I say it's the Linux one. So when I created those nodes, I have Linux nodes and Windows nodes, and so you tell Kubernetes, hey, I want this to go into the Linux node, okay? And then here's my service, excuse me, for the ASP.NET to-do app, all right? And then, again, same thing, deployment. I could make this 2, 10, right? And then Kubernetes would go ahead and make sure that there's multiple replicas of the to-do app on multiple nodes on Windows, okay? And so down here you see, oh, it's Windows. And then here's the image. This is Anthony Howe's image, latest from Docker Hub, right? Okay. So let's go ahead and get this thing deployed. So kubectl create-f. All right, so now it just created the 2 services and the 2 deployments, okay? So we're gonna go ahead and watch this. Okay, so you can see, okay, now boom, now they're both running, okay? Fast, huh? So now that actually is running both the pods on Windows and Linux, and it's already up, okay? And that's not trickery, that's actually how it works. Now, the first time you do this, you will have to cache, I think, the Windows image first. And the same with on Linux. Like, it's got to go download the Docker image. So if you have a big image, right, it has to download that one time. So if it's multiple gigs, it's going to take a little bit the first time.
But if you're running a bunch of containers all based off of the same stuff, it's pre-cached, and the launches after the first one will be just a few seconds.
Yeah, and since I've done this demo so many times before today, they're both cached. So I don't want to make a false impression like, well, on Jim's computer it was really fast. Okay, so I'll get the nodes here, and you guys can see there's the 2 Windows ones are those weird name ones, and then there's the Linux pool ones, okay? So you can kind of see the nodes there, but most importantly, I want to see if the service has has an external IP because I can't really get to the to-do app online if it doesn't, right? So there you see where it says pending right there. So what's going on, and in fact, I should just switch back to here now so I can explain what's going on while it's doing this. So basically what's going on is the master, the scheduler, control manager, API server, all that's in the Kubernetes master. It's scheduling the workloads on the Windows nodes and Linux nodes. So you already saw the scheduling happen, right? You already saw the nodes come up, or the pods come up. The service identifier, we said, well, on one of them, we want an external endpoint. We want it to be port 80. Okay, so what Kubernetes does is it says, well, I need to create a load balancer. So it, based on that spec, it says, oh, okay, I need to create a load balancer that goes from port 80 to whatever I said, port 5000 or whatever it was. And it needs to route to the Windows node. And so it does that for me, basically. So when you define, different services and things in Kubernetes, that's why you have to have the service principal, because you basically just gave Kubernetes the admin rights to be able to create things inside of that resource group or inside your subscription based on whatever your service principal is. Does that make sense? Yeah. So, so let's go back and I can show you my age or 7. Okay, so let's see if that thing's coming up now. And for those of you that do not like CLI all the time, there is another option here. Kubectl proxy. I'm going to go ahead and throw this into the background so it doesn't block. Here. So here's the Kubernetes dashboard. This is a dashboard that just basically comes with Kubernetes, and it's an open source project. So here you can see, okay, there's my ASP.NET pod on Windows, and then there's the Redis. So if I look at my deployments, I'll see that. I'll see I have one pod there. And then if I go to replica sets, you can see that I'm only running one, so it's not as interesting to see. But what you can see is that, so there, remember in the spec I showed that here's what the container looks like for the work, and then, oh, I need a service. Now notice here, that service just came up. So there's my external IP. So if I go back to the CLI, do get service, or if I have the cap locks on it. Okay, so you'll see that external IP is there, but it just is easily accessible through the UI.
And that's the IP of your Azure load balancer, right?
Yes, and then which then routes to the internal pod,
yeah,
which is this to-do app here,
yeah,
right?
And so you didn't have to specify any of those IPs. You just said what you wanted to deploy, and it figured out how to connect all the dots for you.
Yep.
Yeah.
So, I created a few to-dos like, what was that ride we went on last night, Harry Potter?
It was Escape from Green Gods or something?
Yeah, Escape. That was awesome, right? Did anybody get a ride on that? No. We're Harry Potter fans. And then, did anybody wait 75 minutes for Hulk? Was that crazy? Was it good? Was it worth the wait? We were debating. We were like, should we do it or not? Anyway, so you can see these to-dos are, they're being saved to Redis over in Linux, right? So basically, we just showed, Windows, Linux working together. You have a single kind of pane of glass where you can see everything inside of, inside of the portal here, or through the CLI, so you can automate everything as well. So that's it for that demo, I think. Right. Do you want to try to deploy that Windows one to this?
Yeah. Let's give it a go. If I hit the right button again.
Yeah, you're 8.
I'm 8 now. Okay. You really should have swapped those.
Yeah.
It would work if I was standing on my head, I guess. But all right. So now I'm back over here on my machine. So while he was going through that with ACS Engine, I also wanted to just briefly show that ACS Engine is what you can use for the bleeding edge stuff, but there's also if you're looking for the fully supported version, ACS Engine is the technology that's behind Azure Container Service. And so that's something that you can just go and deploy in the portal here. And just like deploying any other Azure service, you have to give it a name, provide all that basic stuff. But then in there, I'd be able to pick the number of nodes, and then everything gets deployed automatically. I mean, that's the real magic of ACS. It's like, has anybody by any chance tried to set up Kubernetes manually? One person?
Google,
Three?
Google training thing.
Oh, okay. You went to an all-day training on it? Could you get it done in one day?
Couldn't get it. No, couldn't.
Yeah, it's hard.
Everything works great once it's deployed, but there's a lot of steps. And so, the real magic of something like ACS Engine or ACS is it's just done for you. And it's been done in a way that's been, tested and hardened and really tuned to work great on Azure.
Yeah, and I'd like to mention too, on ACS Engine, like one of the popular use cases is, let's say you have existing VNets for the way you have everything secured, especially if you're doing something hybrid. You're not going to be able to just use ACS. You need to use ACS Engine and define your existing VNets and things like that.
Okay. All right, so anyway, so I've got that app that I built earlier that I had already pushed to Docker Hub. And so the next thing I needed to do was basically describe how to deploy it in Kubernetes. And so I actually used a tool called, it's misspelled, it starts with a K because it's Kubernetes, but there's a tool called Compose that I used. And if you look closely, I'm actually running this in Bash on Windows. The reason I did this is this Compose tool hasn't been ported to Windows yet, but I don't actually need it to be ported to Windows to use it, because on Windows 10 and also in the new release of Windows Server, we've announced that this is right in there. So I just went in there, downloaded the binary, and one of the fastest paths to productivity is reusing existing code. And so I just copy and pasted stuff, example steps directly from their website in order to get that installed and up and running. And so that let me quickly take some of the code that I already had and convert it into the right format. And just to show a little bit about what the deployment actually looks like, this created 4 files for me. And so what it did was it looked at the containers I wanted to deploy, and it basically just filled in the rest of the details for me. So what I'm going to do here is deploy the web service. This is an ASP.NET 4 app. Then all I did was repackage it in a container and then ship it up to Docker Hub. So it's going to deploy that. So within the container spec, you can see what container image it's going to deploy. I want to open port 80. That all the basic stuff I need to describe how to deploy it is all done in this file for me. And then, of course, I want to be able to expose port 80 behind on a load balancer, so that way you can get to my live service. And then, same thing for the database and so on. So since all those files are code, I'm just going to use them as is. So I'm going to do kubectl apply f tb deployment. So I'm going to deploy the database stuff first. It doesn't actually matter what order I start these in, because if they fail, it'll just restart them until they succeed, but I'll get to success faster if I just deploy them this way. So I'm deploying the database, deploying the service for it, and I don't know if we mentioned this earlier, but a service in Kubernetes terms is basically just an endpoint. It could point to a particular container that's running that service. It could point to a load balancer. You could even configure it to point to an external service that's running somewhere else. And what's really important about that is that gives you a way for your container to figure out how to connect to its database in this case, and without me having to go and code that in the container itself. In the container, I just say, connect to DB, and if it does a DNS query, it finds it, and then it connects to it. And that's great, because then I can go ahead and move that container from one environment to another, and all I do is just make sure that there's a valid service for it to point to, and it'll get up and running. Okay, so I'll finish running my last couple files here. Okay, so I've run all 4 of those. And then if I run, the same, kubectl command, I can see that, okay, both the deployments are there, but I don't particularly like reading tiny text like that. So I'm going to go ahead and actually go ahead and bring up the, bring up the dashboard again. So browse. And one of the things that's great about ACS is that it's tied directly into the Azure UI. So I didn't need to figure out what the IP was or anything like that. I just told it to connect to the browser. It started it up for me, and then I'll go ahead and connect to it over here. Let me refresh this so that it's connecting to the current instance. All right, so now we've got the Kubernetes dashboard again, and within here, we can see both of the deployments. And so those described what needed to be done. The pods are, what wrap around the containers. And so we see that it's got 2 pods deployed. One's the web, one's the database. And then down here, we've got the services. The database service is up. And what's really cool here was when I deployed the database, I told it that I want it to be internal only. And so it's only going to be exposed to other pods that are running within my same installation here. So this gives me a really great way to segment out what I want to be, internal private traffic versus what should be done externally. And then on the web browser, on the web server, that was the one where I actually said that I wanted a load balancer there. It's in the service, not the deployment. Yeah, and so I just said, give me a load balancer. And because I'm running on Azure Container Service, they've got a plugin that's already installed that's going to make that the Azure load balancer for me. And so let's see how things are looking here. We got a failure. We'll have to debug that. So what I have right now is the web deployment's in a good state. I've got the nice green checkbox. And then database, liveness probe failed. What happened here? Error syncing pod, back off. Oh wait, the failure's right here, and it said, here's the command that failed. So let's go look at what is actually in this deployment. So right now I'm looking at the database deployment that is now in a failed state, and what's going to happen is Kubernetes is going to try to restart this automatically. But I realized that, sometime after all those rides and beers, I must have messed up this command line here. And so what I'm going to do is I'm just going to go fix that. So even though I'm using the Kubernetes dashboard here, everything behind the scenes can still be done as code. And I can actually just go ahead and modify this deployment right now. So the first thing I'm doing is I'm setting a new generation here. So all the deployments can be version controlled. And so that lets me track what version of the deployment configuration is actually there. So rather than simply deleting everything and starting over, I can just say, no, I'm going to make a revision. So this will be the second revision here. And then I'm looking for my container definition here. There again, there's my insecure password, but it's on a private network, so don't do that. But you can't hack me right now. You'd have to break into something else first. Okay. Oh, there it is. Okay, so the liveness probe. I made a mistake there. I kind of messed that up. So what I'm going to do is just simply remove that section from the config. And so it's not going to know how to check the health of that service anymore, but at least my check for the check isn't going to fail.
Check for the check.
All right. It says DB object has been modified. Please apply your changes. Wait. Don't change the right thing. Okay, so generation 2. Just scrolled past it again, I think.
There it is.
So remove the liveness probe. Save generation 2. Is there anything else I need to change, you think? Okay, there we go. I must have hit copy last time instead of update. Okay, so I've updated that. And let me go back here to the overview and let's see what happens. Okay, so now all I did was update that deployment. I didn't change anything that was in the container, but now that it had new instructions on what should be deployed, it's working on making it so. So right here, waiting container creation. And of course, because I only changed one of the containers, the other one is still up and running. So it was smart enough to just figure out what needed to happen and then just tweak that one setting and then start a new container in its place. And so while that's starting up, let's go ahead and look at this. So while I was fixing that mistake I made as a tired admin, looking in the services, I see that now I've got an external endpoint here for my website. So I'm going to go ahead and click that. And this is probably going to fail as well, but it's because the database isn't there quite yet. But we'll get it up. So since this is the first time I've hit that web server, it's probably working hard to JIT all that stuff in the background right now. Oh, it actually succeeded. That was surprising. So I guess in the time
True development. Right
well, you know, like I said, everything retries until it succeeds. And so in the background, what happened there was this database deployment actually finished. And so if I go over here and look at the pod health, now it's running again. And so I've got my application up and running. You know, I can show you it's live. I'll go ahead and create a new trouble ticket. Create a new trouble ticket, and I think that take a nap, you're making mistakes. All right, so got a new trouble ticket created. Go back to the list of tickets, and there it is, there we go, and I need to actually assign that to somebody else. But anyway, this existing .NET application that we've been using for years ran with no code changes. All I did was package it up in a container. I tested on my local machine with Docker for Windows, just as a developer would, and then I pushed that code up to Docker Hub, and then I used Kubernetes running on Azure Container Service to actually deploy that. And so I did all that from the command line just to save time, but you can also actually deploy straight here from the Kubernetes dashboard. So I'll get one more site up real quick. So let's say I wanted just another web server. I'll say web ignite web 1 Microsoft /IIS. I'll say number of pods 1. Okay, that's fine. And then for service, make it external. And I need to specify the ports, 80, 80. All right, and let's deploy. And so I just created a new deployment from the UI, but if I go and look at this deployment, I can actually go grab all the code that it created for me. So for a lot of common deployments, if you want to use the UI, you can do that, but this deployment code behind the scenes is something that's completely reusable. So, I mean, I could emails to somebody else, or even better, I could just go ahead and put in source control next to the application. And so now, anytime I want to deploy that application for a security patch or whatever, I already have all the instructions to deploy it right here. All I have to do is hit apply, and then it'll run. So going back over here to the overview. Okay, so now the new website's up and running. This is just the vanilla IIS site. And right now it's working on getting an external endpoint. Is that done? Yes, it's done.
Boom.
And there we go, it's already up and running. So deploying a new application took just a matter of, what was that, a minute or so?
Yeah.
I mean, it's quick and easy, and that's part of the power of what you can do with containers. All right, so let me go and switch back over here.
Yeah, okay.
All right, so that was hosted on, so that was Windows containers running on Kubernetes through Azure Container Service. If you want to know some more in-depth content about ACS, there's other sessions. I'll skip forward because we're actually taking longer than expected because I keep breaking stuff. And so that
good.
deployment had
Good way to learn.
two containers. I had the database and I had the web server. I broke my configuration, but I was able to fix it, and now I've got the site running. And so let's talk about some of the other options that we have as well. And so I'll hand it over to Jim.
All right. So most of you are probably aware that we have a pretty tight partnership with Red Hat, right? So, so they have an awesome product called OpenShift. Basically, think of OpenShift as, you know, it's the base is Kubernetes, but then they have a bunch of services that sit on top of it to make it easier for enterprises to get started with things. They have a nice UI. I'm not going to go through every single feature that OpenShift has, but I am going to demo it, managing Windows containers, because we've been working with their team a lot to try to get this to work and to get a fully supported OpenShift in the future to where you can manage your RHEL containers and your Windows containers with one pane of glass. But just a few features that they have a container image registry. They have software-defined networking, operational management. The source-to-image tool is very cool. You basically stick in your GitHub repo, and it builds it for you. I'm going to go ahead and show that. And not only does it build it for you, it pushes it to a private registry, which is also inside of OpenShift. They have their own private registry. And then it does all the monitoring for you, the log and metrics. There's awesome security analysis, and then it's got advanced RBAC, so role-based access control within the pods. Right? So, you know, all those enterprise features that we're all used to, kind of on top of Kubernetes. So we're going to go ahead and show some of the work that we've been doing with these guys. It's been a lot of fun working with them. CM7, right?
Yeah.
I have some kind of flash on me from one of the Red Hat guys. Hi. So, all right. So what I'm going to show here today is, you know, a typical scenario is you have an old Java app, right, internally, and maybe it's running on JBoss or Wildfly, I think it's called. And then you also have an old .NET app. Let's say you have a .NET 3.5 app, and so you'd like to move into a more modern architecture, a more modern framework. And so I'm going to show you how you can do that within OpenShift. So the project here is Windows. I created a project called Windows and RHEL. I'm going to go ahead and add a couple different projects. So I grabbed this kitchen sink example. I didn't know specifically which one to grab, so I just kind of grabbed my own. So I'm going to say JZ kitchen sink, and JZ's because I'm Jim Zimmerman, and so I just put that on everything. And then I need to grab, I couldn't memorize this, so I needed to copy and paste. And so basically what's going on here, we'll go to the logs so you can kind of see what's really going on here. So it went and downloaded the repo, and now it's building the image for you. Awesome tool, right? Because now some people already have their CI/CD pipeline set up, so you may not need this. But for those that don't, and having everything kind of in one solution is actually kind of a nice thing. So basically, this is downloading everything. It's going to compile. It's going to build an image. We're not going to sit and watch it because that's kind of boring. But as you can see, it's doing all that, and we'll visit this in a minute here. So go back to my project here. And then now I'm going to go ahead and add a .NET app that I already have put in here. So I'm going to do my same convention and put JZ. I don't need a port. Everything's kind of defined for me. So, oh, see, it already exists. I knew it. I told you I was going to.
you said you were going to increment the number.
I know. I knew that was going to happen. So we're going to put 3 because I know I haven't done a third one yet. So we're going to go ahead and continue the overview. So now you can see the Windows app's already up, and the reason for that is because I already had the image in Docker Hub. So this isn't, I'm not doing a source to image and deploying to Windows. We don't have that working yet. That's something that we're going to have to work on with the Red Hat guys to do the build and deploy to Windows. They have build and deployed ASP.NET Core to Linux, but we need to make that work with Windows. So that's why you're seeing that come up so fast. So if we were to dig into here, pretty cool. The container's running, obviously. But we added this feature, which we thought was kind of neat, where you go to the terminal and DOS prompt, right? Who doesn't want to have a DOS prompt in your container? What's the cool command run? I'm kind of more of a Linux guy, so I don't know the...
Run wmic.
wmic?
Yeah.
And then OS?
Yeah. Yeah, that'll tell you what OS we got here.
There we go. See? It's the real deal. So, what? Yeah, yeah. One's from the crowd. Let's try to break this thing. Tree? I don't even know what that is. Is it crashing the container now, or what?
That's
malware.
No, that's a stress test for our console redirection, is what it is.
I wonder if Control-C works. Man, okay, well, that was unplanned. Awesome.
Good job.
Let's refresh this guy. I think I just crashed my browser. Cool. I love unplanned things. Okay. So let's go back to here. Yay, I can get to it. So and you can see here, what's pretty neat too is I can go ahead and scale the pods, right? So now this actually really is talking to the Windows server as long as that tree command didn't like totally screw up the server. So if we go here, we can see, it's creating those containers now, okay? So nice UI, able to do that. And we'll go back here and we'll see that, it looks like the Java one is up now too.
Oh, cool.
Right? So the thing here is that you can deploy multiple projects and have one administrative interface to do it. And so you can have multiple teams. They can have the way that they do their DevOps. The Windows guys and the Linux guys tend to have different patterns in the way they do things. But if they all have a GitHub repo or whatever, some Git repo, and they publish their Docker file and everything to that repo, then OpenShift can build it and deploy it, right? And so that kind of takes care of that. Let's see. I don't think I had anything else on here. So I think that's good. Yeah, I showed how to scale it and DOS prompt.
Yeah.
And tree.
Yeah, and we started from both containers and started from source, and
yep. Yeah,
got a successful build and deploy.
Cool. So so why don't we close this out and do some questions here in a.
Let's count down to 15 remaining.
Yeah, so we can do that for Q&A, right?
Yeah, we're doing good.
Okay. Yeah, we're on time. Yes. All right. So that was the demo that you just saw. So I didn't move to the right slide before I did it. So. All right. So what's next on Kubernetes on Windows? What's our vision?
All right. So Windows Server containers are something that we've developed over the last couple of years. But the first release was, just about a year ago with Windows Server 2016. So so at that point in time, we were able to run containers, but because we were so early on that journey, running Kubernetes was still a little bit difficult. We had to do some workarounds. So an example of that was that we only were deploying one container per pod, and we had to set up multiple network interfaces. One for ingress and egress traffic, public, and then one for one pod to another. And but that's something that we've been moving to actually improve as we come into this next Windows Server version 1709. It's a bit of a mouthful, but that's what it's called.
Where do you get 1709?
1709?
Is that how many builds there's been?
No, it's 2017, September.
Oh. I'm fairly new to
Yeah,
Microsoft, so
yeah.
probably not the place to be asking.
It's a date. So basically, Windows 10, they've had version, they had like 15.10, 17.03, and then there's going to be a 17.09 as well. And so server just decided to match that. But that's part of the new releases that we're doing on the semi-annual cadence. So twice a year, we're going to be shipping a server release and a Windows 10 release. That's just the new pattern of doing business, which is fantastic because when we're working with agile open source projects like what we're doing with the Kubernetes community, that means that we've got a much better chance to make the changes in Windows that are needed to enable the coolest features in new open source projects. And so some examples of that are, we went back and made some changes to the SMB stack so that we could actually go ahead and, on a Windows host, go ahead and create volume mappings there, and then you can pass those into a container as needed. That means the container doesn't even need the credentials to connect to that network storage. So now you can just have a pool of machines running whatever containers you want. They don't know what the creds are, but yet you can still put the storage where you want. And we've got that, we've got a contribution going back to Kubernetes to have a plugin to do Azure Files, which is going to be based on that. So Azure Files today uses SMB. So it's a great way to be able to give persistent storage to containers where you need it. And then we've also been hard at work on the networking side. Our networking team has done a fantastic job going from nothing on containers to having something that's extremely sophisticated and fast in just a matter of 1.5 releases basically. So now they've got a CNI plugin. That's the standardized plugin model in development, and then moving forward, they're continuing to engage with the community to support different networking models. Because if you go and look at the Kubernetes page today for networking, you don't have 1 or 2 choices, you've got about 8 or 9. And so we're working on making sure that we're aligning with some of the most popular ones there. So that way you can deploy on your existing environment and be able to have Windows and Linux machines talk great together. And then also continuing the work we're doing to enable isolation with Hyper-V where you need it, but be able to still support all the cool features that Kubernetes has, like pods. So that's some of the journey that we're on right now. But you're going to keep seeing more and more from us as we go. So in closing, where are admins spend their time today? Well, they're maintaining existing applications. Well, we did that. We did it. Diagnosing issues with existing applications. Well, yeah, I broke stuff and it wasn't too painful to fix it, so yeah, whatever. Redeployed some existing applications, yeah, no problem. All I did was take a container, a few clicks, and it was up and running. And we also got to deploy some new applications, so I think we're good. I'm a lot happier than I was without containers a few years ago. So
A lot quicker.
And also, don't forget the recordings. So earlier this week, we had a number of sessions that were focused on app migration and modernization. Those top 2 on that list are great if you're looking at how to get started moving and modernizing apps. The third session on the list that Taylor and Callie did covers a whole bunch of new things across the Windows Server release. But one of the things they showed off was also how easy it was to use Docker Swarm, because we didn't just improve the Kubernetes experience in the new release, we also implemented Docker overlay networking and ingress mode, which is awesome. It works great. Mani from the Azure Service Fabric team had a great session where he showed Azure Service Fabric and then showed the massive scale it can handle. And then if you want to go a lot deeper and see more about how Kubernetes works, along with other tools like Helm and Draft, Gabe and Brendan Burns each did sessions that were focused more deeply on Kubernetes and its integration with Azure overall. So, all All right. Well, thanks everyone for coming out.
Thank you.
It's the last session of the day. I know a lot of people have to get to the airports, but we're here for questions, and so thanks.
How do you get started?
Thanks.
Okay.
How do you get started?
Yeah. So for the questions, be sure to get to the mic for recording. But the first question was how do you get started? So probably there's kind of two different paths you could take. If you're deploying on your own site, if you go to the Kubernetes site on GitHub and go to the SIG Windows page, they've got a getting started guide there that shows how to deploy what's needed there. So you could follow that up and get something up and running. It's not fully automated yet, but at least the steps are documented on how to do it. The fastest way, of course, is to go ahead and use either ACS or ACS Engine, because Azure Container Service today is in preview for Windows, and that was actually what I did all of my demos on, was the same code you'd get through the portal. And it's labeled preview, but it works great, and they're working hard to get that to GA. So, next question?
Yeah, good.
Uh-oh.
Yeah, I don't know if
the mic's not
mics
working.
are on. Oh, there we
Oh,
go.
there we go.
Okay, hi. What is the state of Kubernetes on premises on Windows? Is it doable or not recommended yet, or?
Well,
Yeah.
that's an interesting question. So it's not ready. But
Well,
For the record, that was in the description of this session. It said Kubernetes on premise.
yeah. So,
well, it said on Windows actually. But,
yeah.
But
No, read the description. It says
but you can run it on-prem.
Maybe to clarify the question.
Right.
Probably, but
Yeah.
the question is.
I mean, if you can run it in Azure, you can run it on-prem.
Yeah. So I mean, the stuff is there. I just didn't go through the whole
Okay,
setup
but
on
is it
premise.
mature enough to try at least, or it's?
Yeah.
I understand that you got your Azure thing like solved and quite mature, but on premises, it's kind of not the same. So.
So I've
Yeah.
never installed Kubernetes on-premise, but you'd have to install it, on Linux,
Okay.
and then add the Windows nodes, because the only thing that works on Windows is the proxy and kubelet. So
Yeah.
it can be a node, but it can't be a master. So
Okay.
if you set it up on-prem, you can set it up on-prem, but you're gonna have to do it on your own. There's no
Yeah.
auto magic installer thing. Now, the work we're doing with OpenShift should make it easier to do on-prem eventually, because OpenShift installs on-prem with a nice installer and everything. And then you could add Windows nodes to it. But in terms of like us releasing code that says, oh, this is how you install it on-prem, maybe if you have an Azure Stack machine,
Yeah.
we would have something that would be a little bit easier. But
Yeah.
that's a whole nother conversation.
Yeah.
But, yeah.
data sovereignty, containers.
Yeah.
I can't spend 300 grand.
Yeah, no, we understand that.
But I mean, that's great feedback. I mean, right now we're getting the technology working, and then we're working with Red Hat and others to make sure that we've got an easier way to get this deployed. So we're working on it.
Kubernetes on Red Hat, and then add Windows nodes to actually run Windows containers.
That's what the path would be for OpenShift, is you'd start from an
on-prem,
existing OpenShift install and add the nodes.
Yeah, especially if you want like support with Kubernetes on-prem. I think that's really only one, or I think there's a couple.
Okay.
You have
I
questions?
was just to say, to follow up those two questions. So there's obviously the 2016, the 1709, and the whatever. As people are looking for less friction, like there's people who are early adopters and want to play,
Yeah.
we'll do that. But as far as organizational pitching that this is going to make things easier, do you think that's 6 months out, 12 months out? Where does it get to that point where it's easier to do this than to do VMs and all the stuff that people are already doing?
I'll let him answer that. Because you're talking about Windows specifically.
Give me the hard ones.
Windows, same questions as the other guys.
Yeah.
Kind of trying to figure out, where's that horizon? Because we're going to start playing with it, but cost value, it's not going to make sense until some of these frictions are gone.
Yeah, I mean, it's hard to say exactly when that point would be, because it depends on the types of apps you're trying to migrate and what you're trying to run.
Yeah.
Because I mean, like if you're writing stuff today and you've got the code and you're starting in container, then it just makes sense to just start in containers and start cloud native from the very beginning. And so I would say, that's ready today. we've got the services there on Azure, go ahead and use them. When you're starting talking about integrating it more deeply into existing infrastructure, that's a challenge for containers today. You know, it's like we started down the journey with things like, you know, Active Directory service account support, and that works for many cases, but, you know, we're still getting a lot of questions around, well, what about this legacy component? What about this legacy component? And, you know, we're still a first year in, so,
Oh, yeah.
I mean, so everybody's still learning and sharing, and, you know, what I really like is we need to make sure that people are sharing more stuff on the forums and everything like that in terms of what apps work and what apps don't. Because, you know, I haven't tested all the apps in everyone's data center. I've only tested some of the stuff that's in Box and Windows, so.
Yeah, and in two of our use cases, this may extend, the data sovereignty is one thing. Developer story, you know, as we have more and more like Azure assets and things like that, the
Yeah.
ability for a developer to be able to pull down a working set of 14 different things that all have interdependencies. It's
Yeah.
a much better story if it's Docker than having to pull down
Yep.
source, compile them, get
Yeah.
the ports right, that sort
Yeah,
of stuff.
yeah, definitely.
And then two, because of hybrid cloud, the goal is to become more cloud heavy. Containerization hopefully will make that easier.
Yep.
So that way we're not dual deploying, because right now we have a NuGet Octopus kind of methodology on premise.
Yeah.
And so those are our two use cases that we're trying to
That's
get
good.
better at. So,
Good info.
good
Yeah.
work.
And I think we have one more question, and I think we're over time, so.
Yeah, it kind of dovetails on a lot of what's being spoken. All the stuff that's occurring in Azure is really cool. Some of us have some challenges of getting things into the cloud due to like privacy issues or
Yeah.
compliance and a whole bunch of red tape that we love with our bureaucracy. So things like ACS, what's the roadmap for that and integrating it into, as you said, like an Azure stack? Is that something that's going to be native out of the box with a future release of Azure Stack, and how much is going to trail from Azure?
So I could answer that. We're working on it. I started to get ACS deployed to Azure Stack last week.
Cool.
So it's new development, but you know we're working hard to get it working. You know, there's a few nuances with the APIs and you know making sure you have Azure Stack machines that are in GA to actually test on, and so getting all that set up, it's not trivial. But yeah, we're definitely working on it so that it will be supported.
There's one thing it'd be nice to get development to say, okay, let's kick the tires on an ASDK for a single node just to try out, get used to it, still doing your traditional ghetto style, old traditional app methodologies, and just trying to give away, but it's without having a platform to help evangelize with, or without doing a $300,000 commit.
Yeah, exactly. So there is you can get like as long as you have like. I would suggest 256 gigs of RAM on a workstation with like 12 to 16 cores. You can get those for under 10K at Dell, and then just install the single Azure Stack SDK. That's what I do at work.
Yeah,
It's definitely not production, but it's a way to play
yeah,
with stuff if you're trying to figure out that model, if you have time to research it or whatever.
yeah, cool. Thank you.
Cool. Maybe, I don't know, do we need to close down or can we take more questions? Okay, yeah, go ahead.
So my question is, during all the demos, I say all the demos, but a lot of demos, you spin up a SQL server during the deployments. Do you see any issues running SQL Server in container environments, or I mean, we're not getting HA because we have a single node. Is there a way to do 2 nodes in there, or that you're aware of at this time?
Yeah, so SQL HA is not supported in containers. I mean, my recommendation if you're running on Azure is rather than trying to manage HA yourself, just use the SQL Azure databases that are there. In terms of running on your own site, probably the approach I generally recommend is move the app first, leave the data where it is. Because you've already got a process in place to keep those databases highly available, and you've got a backup strategy. You don't need to throw all that away right now. In terms of when SQL's ready to run in containers, with all those features, I mean, I can't speak to their roadmap there. I tend to use it because it's really convenient when I'm working with existing applications. And I don't even have to install SQL. I can just bring it up and use it. So
Yeah, and it's still early days on really any database or data platform running in production HA on Kubernetes. I don't really see it much
Okay.
at all. Like it's just, most people don't trust it yet for that.
Awesome, thank you.
Just, yeah.
So this is more of my own experience, see what maybe I might have done wrong. So I basically set up a Kubernetes cluster, use the ACS engine, build it, and basically to be able to connect to my own VNet, back to an express route, back to, do I connect to on-prem resources? However, when I set it up, I had the Windows nodes, they were able to talk to the systems of my on-prem stuff. My containers, however, could not. So I'm trying to see what I might have done wrong in the configuration, or if there's some problems with that.
Why don't I get your email and I'll connect you to an engineer that can help you
Okay.
figure that out, because it's pretty complex and we're like,
Yeah,
you have to debug the VNet and like there's a bunch of things that you have to figure out. And then there is a networking thing, I think, with one of the pods in Windows. But yeah, well, give me your email and I'll connect you to an engineer.
And then also, see if there's any issues tracked under ACS Engine on GitHub yet.
8 months ago, so.
Oh, okay.
Oh yeah, try again.
Yeah, I mean,
There's networking
there's been
bugs.
there's been a number of bug fixes over the last year. So.
But I'll definitely give you my email address and you can.
Yeah, I can connect you to the right people. All right, thanks.
All right, well, I gotta get going.
Yeah,
Thanks, everyone.
Plain.